hello. This is kind of different for me. This is the first time introducing a new rocket, again, a 3D printed rocket, to the channel. This is only my second time doing it, and this time it is this small, cute little rocket that will serve out a very small task to test a theory I have. So this is the introduction video. There will be a launch video in the future, not sure when, but this today is demoing Axis. So, Axis is a very small, one-stage, fully 3D printed rocket that will be utilizing A-class rocket motors, possibly in the future B and C-class rocket motors, but I don't see this rocket having a very long lifespan. So, each one of these rockets will be launched one time to test it one time, and then it will be put on the shelf forever if it's recovered. Otherwise, it will just be lost to the field and we will have completed our test. Now, Axis is very special for multiple reasons, so we're going to go ahead and go through those. Reason number one that Axis is so special is because of its sheer size. This is the smallest rocket I've ever built, designed, constructed, printed, whatever you want to say. This is the smallest, and we'll be utilizing the smallest motor I've ever used. And it is simply to test one theory and concept that I have that may be scaled up to larger future rockets, but I need to test it in the small scale. Now, Axis is made up of two prints. It's an upper nose cone section and a lower main body section. All in all, it's less than a foot long, including the portion of the engine that stays protruded. It sticks out a bit so that you can still read the text of the engine. Even though it is printed in two sections, it will not blow apart and release a parachute. One, because they don't make any parachutes small enough to fit in a rocket like this, and two, this rocket really isn't going to need to be recovered via parachute. If this rocket is recovered, we will just go out and find it and pick it up again, and the engine is placed in the rocket to be used once. So this is a one-time flight rocket. It is a super small rocket, two pieces, no parachute. It's going up, and it will be testing something through this launch, and then we will watch it, try and find it wherever it landed, and from there, Axis's mission will be done. So because Axis is a one-time launch rocket, Axis is more of a program than it is one rocket. RP1 is one rocket, whereas Axis is a program, so this is Axis 1, and if we launch another one, that will be Axis 2. Currently, in this Axis rocket, I have a half A motor loaded. I also have some A motors, so we will first launch it with a half A, then a completely separate rocket, Axis 2, will be launching with an A. So, to get to the point of Axis 1 was simply booting up Inventor, designing the lower, and then designing the upper portion. The upper portion failed one time. This is the failed print for the upper nose cone section. There was a little power blip, and the printer stopped. Because it was so early on, instead of having it just continue from where it was, because my printers are both capable of doing that, it was so early and so little material that I just went ahead and threw this out. Well, it's right here. I just went ahead and cast this to the side and started over again. I also printed the lower section, which was only one time, and I printed it all in this gray AIO Robotics PLA filament. So as far as the design, Axis is it's a gray rocket, a real dark gray. It has a blue tip up here at the top. We'll get close-up footage of all this, but the top is blue. There's also a stripe that is blue around the circumference of the rocket where the two pieces connect, and the fins or winglets are traced blue down the edges and then down their bases. So it's a gray rocket with a little bit of blue. I actually think it looks great. And it's really, really weird holding this little small rocket. Let me go get RP1 real fast. This right here is RP1, which could be considered the big brother or father of Axis. Not really, but the only way that you could consider it that is simply due to the fact that these are both prototype rockets, testing different things, yes, but since they are both prototypes, I guess you could lump them in together. This is Axis standing up on its own. I can't stand it up on just the motor very well. Actually, I can apparently. That is Axis standing up on its own, and this is RP 1.1 standing up on its own. So a slightly larger rocket, both in diameter and height, obviously. RP 1.1, at this point I haven't filmed the video for it yet, but there will be a video detailing all of the changes made between the RP1 and RP 1.1. It is the same rocket at its core. After the first launch, it has had multiple design changes, so because there's been enough design changes, it both warranted a slight change to the name, RP 1.1, which it'll generally be referred to as RP1 or the RP1 rocket program. At its base, it is still RP1, but more specifically, to refer to this current block or model or generation, this is RP 1.1. And there will be a full video detailing the changes between RP1 and RP 1.1, why all those changes were made, and then after that, a separate video for the launch of RP 1.1, which currently isn't scheduled, so I'm not sure when that's going to happen. I'm not sure when I'm going to film the detail change log for RP1 changing to RP 1.1, but that will be happening down the line. This video is focusing on Axis, and I only brought RP1 out to showcase the scale of Axis versus RP1, so we can go ahead and put this away real fast. So you might be asking yourself, Josh, RocketMax, why did you create Axis? What is fundamentally different about it that forced you to create an all-new rocket to test this great theory or thing that you want to witness for yourself? That is a great question. I'm very glad that you asked that, and I will tell you right now. So the main thing that's different about Axis is the fact that its fins, all four of them, are canted to the side about 5 degrees from completely vertical. This is to test the idea of spin stabilization. Spin stabilization is something that most rockets don't do anymore because they have active guidance systems, RCS. In the case of the Falcon 9 coming back, it has grid fins along with reaction control wheels. It's just rockets don't really need to spin stabilize anymore. But in the early days of rocketry, when there wasn't much tech in them and you just kind of lit them and let them go, spin stabilization was a great way to keep them going straight. Like a football. You put a little backspin on it and that causes it to go in a more straight line. So the theory with rockets is, if you put fins that are constantly making it spin, and you're forcing an induced spin on the vehicle as it goes up, that corkscrew and spiral as it spins will cause the rocket to stay in a straight line, going straight and true, higher and faster. Now I'm testing this on a small scale because obviously RP1 is my main prototype rocket and kind of my workhorse rocket right now. It's the thing that I launch to test certain things, I make changes on it to test things, and all in all is my main rocket. However, the bottom section where the wings are actually attached has been very thoroughly designed to be exactly what I need for that rocket, so to alter it in any way would be very difficult. So I decided to make a very small rocket using some half A and A class rocket motors that I just kind of had laying around. They've been sitting in drawers. I have 4 of each. So I decided I might as well take some of those, design a rocket around them with this theory integrated, and launch them off and see if it works. Again, they're so small it makes no sense to throw a parachute in them, and so because of that, once you put a motor in here, it is locked into the 3D printed frame, and this is now one unit that will launch one time, test my theory, and then we will launch Axis 2. If this is collected, it will become a little trophy piece, and who knows how many Axis launches we will have. The upper portion takes 2.5 hours to print, whereas the lower portion takes just over 3.5 hours, so all said and done, I can print about 2, maybe 3 if I'm really diligent, of these in a day. Not to mention that I have these rocket motors sitting around, so I can just kind of throw one of these together real fast. I included at the beginning of this a short little build montage, just the painting process with these little Sharpie paint pens. I didn't show the 3D printing process because I would assume all of you are fairly familiar with 3D printing, and just the main assembly. So this is Axis. This specific one is Axis 1. It will launch one time. Then I will be printing out Axis 2 tomorrow, as it is fairly late at night, so Axis 2 will be printing tomorrow and possibly Axis 3. Axis 2 will be running an A-class rocket motor, and after launching both Axis 1 and Axis 2, I will be deciding what I want to change going into Axis 3, and overall just kind of make Axis 3 get me all of the data I want. So, the Axis program of rockets will be a series of rockets launching with no technology on board, simply a motor stuffed into a 3D printed airframe, so that I can video and test something and launch, and then hopefully go recover it from the field, hopefully undamaged, to become a trophy piece of the Axis launches. And hopefully this will give me the data I need to know both what degree to tip the winglets to, and whether or not it's even worth it. RP1's fins are all straight up and down, and while these have a more complex wing design, which I will show you, RP1's wings are a straight up triangle that are straight up and down vertical, whereas these are more complex and canted to the side about 5 degrees. So the other thing that will be tested in the Axis program is while the nose cone will stay the same for consistency, this lower section will have the same winglets changed around. So we will launch Axis 1, this rocket, then Axis 2, this rocket printed exactly the same with a more powerful motor. Then, from what we've learned from those, we will then possibly print... I've already made the 3D design for this exact same lower, except the fins are canted to the side 10 degrees, so double what they are on this rocket. And if we so choose, we may go forward with launching a half A and A version of that. Now, I'm next to positive that this half A will launch this. The question is how high. These motors go really fast. They just spit out a little bit of fuel and they're done. Whereas the A motors go for a little bit longer. If you look at the actual motor, the half A is physically half packed. And you already saw the motor in the up-close shot when I was building this, how small it is. So to think that the half A is only half full, it's a really small motor. And then the A on its own is already small. RP1 uses an E12 rocket motor, whereas this is a half A3 and then an A3. So very small rocket motors, and RP1 is actually ready to fly on even larger rocket motors, so kind of new territory. These are really small rocket motors flying really small rockets to really low heights to test something really, really fast. And everything I said just then is basically the full synopsis of the Axis program, the Axis rocket, and overall what I'm trying to achieve. It's a really short rocket program that I will be running, the Axis program of rockets, or the Axis family of rockets, that will be launched sometime soon to test a theory and see how viable it is in what I'm doing, and whether or not it's even worth considering putting in my rockets, or whether or not RP1's fins are perfect. This also just allowed me to design a new rocket. RP1, again, is a prototype rocket, so it is a rocket that I will be using to learn to build my next rocket. And my next rocket will be more of a workhorse rocket, or possibly a secondary prototype rocket. There may be other prototypes thrown in there, and other real rockets, but this just allowed me to 3D model a new rocket. I went into Inventor and was able to fully 3D model a completely new rocket, and that was really good for me at the base case, because RP1's design is about 2 years old, and if you go back to the first video about RP1, you'll learn that I printed those parts right when I got a printer, and then I actually deleted the files. So RP1 is a one of one. I cannot reproduce RP1 perfectly the same because I don't have the files. So I reproduced the nose cone, and I can reprint those because RP1 just ejects them. It doesn't keep it as part of the landing system, so if it's recovered, it can be used on the next RP1 launch. If it's not recovered, we'll just print a new one. So RP1 is a one-off rocket. The day it slams into the ground, it's done. We're moving on to the next rocket. So, to be able to design a new rocket that in the 3D modeling software still exists, it is a CAD file that I can tweak and edit. And like I said, go from 5 degrees to 10 degrees. I can stretch this a little bit. I can open it up so that I can put C-class rocket motors. I can test different things, and the Axis family of rockets, the Axis program, will be able to yield the data I truly want it to. Whereas at this point, RP1 is a rocket that I have to keep reiterating upon and making what I need it to be. All this said, this is Axis 1. Axis 2 will be printed tomorrow and have a different rocket motor loaded into it. As far as the current launch date, there is not one planned, but expect Axis 1 and Axis 2 to be launching soon-ish. Not really sure. I do have school going on, along with some other stuff, so getting these off the ground soon is not the highest priority, but it is something that I want to do, not to mention the fact that I'm already trying to schedule RP1 launches because I have 2 more E-class rocket motors that I need to fly, before I try and move up to an F-class rocket motor. And again, with RP1 now being in the state of RP 1.1, I need to test these new design iterations and changes before I even consider moving up rocket motors. So I have 2 launches that need to be scheduled for RP1. I have 1 launch scheduled for Axis 1, another one for Axis 2 that needs to be scheduled, and Axis 3 and 4 may also happen. That would be half A in a 10-degree axis and a full A in a 10-degree axis. Not to mention I talked about stretching the rocket or changing the nose cone, so the Axis program could be a decently long one, or it could be 2 launches. I'm not really sure. Axis could end really fast, and it could be one of the longest lasting programs. It's not going to be one of the longest lasting programs, but it is going to be something that could last a little bit longer. But anyways, thank you guys so much for watching. I really hope you enjoyed this video, and I hope that you are stoked for the 3D printing content and for the rocket content coming back to this channel through the Axis program, and also planning on launching RP1 relatively soon. Not sure exactly when. With 2 projects going on at once, not really sure when one will launch versus when the other will launch, when some will get design iterations, whereas some will just kind of sit on the shelf. And not to mention the fact that I have normal vlogs to make, that I'm constantly trying to make. I have school, so there's plenty of stuff going on, so please, be patient with me on actually launching these, and as far as getting new design iterations on these rockets pumped out and launched as well. RP1's actual launch was, at the time of filming this video, I believe 2 or 3 months ago. That's a complete and total guess. That's just kind of what it feels like. It could have been longer, it could have been shorter. I'm not really sure, but I'm pretty sure it launched back in August, so it may have been closer to 4 or 5 months. So it's been a while since we launched RP1, so I hope that you're stoked for this content coming back to the channel, not to mention normal vlogs. So anyway, please subscribe. It is completely free and it helps the channel out a ton, along with the fact that you can change your mind at any time, and it really goes to support what I'm trying to do here with these different 3D printing programs, different rocket programs, and just the general vlogs. But yeah, thank you guys so much for watching, and while you're already down there subscribing, go ahead and slap a like on this video. It will help the YouTube algorithm suggest it to other people, get people hyped for this project. When my projects get hyped up, I'm, 1, able to do a better job on them, not to mention it encourages me to continue them and create new ones. So if you like this content, slap a like on this video, it helps me out a ton. And comment, are you excited for the Axis program? Do you want to see RP1 launch again? What do you want to see in general? What do you want to see in vlogs? What do you want to see through the Axis program, through RP1, and on this channel in general? Go ahead and comment that down below. I would love to hear it. But anyways, thank you guys so much for watching, and I will see you in my next video. Peace.